Hello, le kae na? We are back again. Ke kgopela le invite ditšhomi tša lena to like and subscribe to this page so that re thušaneng ka moka re kgone go puša ka moka. But together each achieve more. So yeah, today this morning, early hours of the morning, re focusa go di-components tše di-important tše e leng gore ba ka se go ruti tšona that much ko matric because they expect gore wa tseba from the lower grades. Ya mathomo ke law of exponents. The law of exponents o tlo di berekiša gantši gomme go dira di-exponential graph or maybe o nyaka go calculate di-inverse or maybe le kae gape mo calculation di-exponential graph. Oh yeah, go differentiate they may say leave your answer in a positive exponents dilo tše di bjalo. So tlo berekiša di-law of exponents gantši ka go grade 12. Mara in general is the same, so re tlo ira revision of what you know by now. If you forgot, then this video is for you, and then we are sharp. Jojo factorization, go na le different types of factorization, so we'll just go through. So far the most common ones ke tše tharo, and then simplifying just to make things simple. It explains itself. Make it simple from a hard one. And then solve for x. That's when we need to know for actually how much is x equals to. We just calculated the quantity of x, solving for the unknowns. So yeah, let's just get straight into it. Law of exponent. So the law of exponent, we all know a to the exponent m very times a to the exponent n. Just because the base are the same, then we add the exponent, the basic one, then what are we over? So am plus n, right? Example can be 2 to the exponent 1 multiplied by 2 to the exponent 3. Then our answer will be 2 to the exponent 1 plus 3, which is equals to 2 to the exponent 4. See, simple as that. Right? And then the second one, law of exponent, when it's a to the exponent m, when you divide, can be written like this, or it can be written like this, depending on how you are. Then because the division sign or division sign more, then you know how the base are the same, then we subtract the exponent, as easy as that, right? And then the other important one, cover maybe when you have the exponent the double exponents, like only a to exponent and then you still have another exponent called n. This is the same as, because the exponent and here in the base, you just multiply the exponent, then it over m to the exponent m times n, because the exponent get paid. I hope you still remember this content. And then in way only a to the exponent 0, any number to the exponent 0 always equal 1. You can say 1 million to the exponent 0 to for 1 and change always. The very important one, maybe how do we do this one? I forgot how to write it. But 1 over 2, you can write it the same as 2 to the exponent negative 1. Oh yeah, I know. This one will be 1 over a to the exponent m, is the same as saying a what is 1 over 1a mara wa negative to the exponent, the way they go on. These are 1, 2, 3, 4, 5 basic rules, the exponents, of which are very important. You're going to use them so often as we go. And then now we go to factorization. We are done with law of exponents. Factorization, only factorization, yeah, the difference of two squares. Difference of two squares, that's when maybe we know the x squared. Maybe let's say x squared, x squared plus 5 plus 5x plus 4. Then there's no way you can factorize this by common factor. The only thing you have is our we read different of two squares, meaning the brackets keep big. Then you're gonna use this and this so that if we are x 5x, so come to by x because the factor x squared k x and x they come to by x. The factor 1 yaga the factor 4 generally they go for 5. The factor 4 come ke 1 ke 2 ke 4. Ha o sa ne eo nomoro e nngwe e tsenang ka go 4. 4 e tsena 1, 2 e tsena 2, 1 e tsena 4. So ke di factor tse di ka go fang go di multiplier ebile o di adder di go fa 5 ke 4. 4 times 1 ke 4 and then 4 plus 4 ke 5 ya mogare. So go dira so ke go factorize by difference of two squares. I'm sorry if you can hear the rain. Yeah, hey, ke summer pula ya re nela go monate. And then e nngwe factorization ke by common factor. E nngwe factorization ke by common. Yes, and then the second factorization key factorized by common factor, meaning you're taking what's common out. You're taking it out and then multiply. For instance, when you have x, I can write x. When you have x minus 4 again x, if you have some x squared, if you have something like this, you can see where there's x in here, there's x in here. Then if you're factorizing a common factor, you just take x out into, meaning how you're going to be say x multiplied by something to give back you this. What is that? 1. X times 1 is going to give you x. Then minus x times whatever is left, it's going to give you the original. Then it's going to be 4 and another x, so that this 2x, when multiplying the same base, we add the exponent, one here and one there. Law of exponent. This will be factorized by using common factor. Another factorize is by grouping. Mara, it's hardly used for interest sake. Maybe you might come across it. Let's say you have x minus 1 minus x into x minus 1. This one is very easy to identify. You just say if these brackets and these brackets are the same, then you just write one, copy one of it, and then open another bracket. In another bracket, you're gonna write the coefficient those are next to the brackets. Meaning here there's an invisible one, then it's gonna be 1, and then here there's the coefficient of this bracket, it's minus x, then it's going to be minus x. Meaning if you do FOIL or simplify, you're going to get to the very same thing. And then this is just grouping, just like that. You just look, inspect, and then from there write the final answer. Right, and then simplify is just multiplying, dividing, multiplying the signs. Don't forget to multiply the signs and the number, and finish up with the variable. For instance, we can simplify this. Let's just, after factorizing it, let's just simplify this, and when we simplify it, it's gonna say x times 1, then it's positive x, right? And then x times negative x is going to be negative the sign, because this one is positive, this one is negative. And x times x, when multiplying the same base, we add the exponent, because here there's 1, here there's 1, then it's going to be minus x squared. And then we are done with this x. We are moving to this one, this and this. It's going to be negative 1 times positive 1, then it's going to be negative 1, because any number 1 times 1 is 1. Then we move over to this negative 1, negative times negative x, negative and negative becomes positive. 1 times x is just x. Then at the end, we will be having like adding like terms. The x goes with x x squared goes alone, 1 it goes alone. Then from there we're going to have negative x squared plus 2x, because we have 2x and they're both positive, then we add them, minus 1 because 1 is just alone. Same, even if we factorize, even if we simplify this, we have to get this to ensure that we factorize correctly when we're using grouping. But now we are doing simplify. Simplify, we are just making everything simpler, meaning we're gonna say 1 times x is just gonna be x, 1 times negative 1 is just gonna be negative 1. Then coming this side, negative x times x is gonna be negative x squared. Then negative x times negative 1 is gonna, negative and negative will be positive. Any number times 1 is that number. Then we see you end up having this x and that x being like term. Then we just write negative x squared here, and then plus 2x, because x and x makes 2x, and then what's left is just minus 1 because it has no other like terms. Then you see this one and this one are the same, simply meaning we just factorized by grouping, and then by multiplying we are simplifying. Sure, you understand the relationship between simplifying and factorizing. So solving for x is just finding the unknown. We're going to use all these three techniques to solve for x. For instance, let's say you have x squared is equals to negative 5x minus 4, right? Before you factorize, you must make sure that on the other side is equals to 0. So you take everything to the left. Now we are simplifying. X squared plus 5x plus 4 is equals to 0. Now, since there's nothing we can do, it simply calls us to factorize. And this thing we already see, this is the same as that, meaning we can replace this with this simplification. And then we end up with what? We end up with x plus 1 bracket multiplied by another bracket of x plus 4. Meaning these two brackets is equivalent to that, we just replace with that and have is equals to 0 on the other side. From here, then we can say this for this equation to be 0, this bracket must be 0 or the other bracket must be 0. Then we end up with x plus 1 is equals to 0, or x plus 4 must be equals to 0, because when multiplying any number with 0 it becomes 0. And then here we simplify by making x the subject of the formula. As well, here we make x the subject of the formula. That's it. Then we have solved for x. By using factorization, it has helped us to solve for x in this case. We can use the law of exponent to help us solve for x in other cases. So all these are the techniques which you should have, or you are well equipped with by now, and will help you solve so many problems as time goes on, and pass your matric and be the best you can be. Thank you.